Hello, my name is Kevin, and welcome to Algobatics. Today, we are solving for the maximum subarray value. This is question number 55 on LeetCode. Let's have a look at the problem. Given an integer array, nums, find a contiguous subarray containing at least one number, which has the largest sum, and return its sum. So what that means is for an array, such as this one, our desired output is 6, because 6 is the sum of the subarray within this array that is the greatest. That means you cannot have a contiguous subarray within this array that is bigger than 6. If our inputs are entirely positive, then we simply sum up the array, as is in this case. If there's only one positive number, then obviously that by itself would represent the largest subarray. And if there is only one value present in the array, then we must simply return that value. Okay, so here's our algorithm. What we're going to do is we are going to declare two variables. One we're going to call max sum, and the other we're going to call current sum. So what we want to do is we want to dynamically update the current sum as we traverse through the array, and then use that to update the maximum sum, which we will eventually return. Now, since we have to cover for that base case of the array containing only one value, we are going to say that both max sum and current sum begin at the first index position of our array. Cool. So now we're going to run a for loop going from 1, because we've already covered 0, up to the length of the array. And then within our for loop, we're first going to declare a variable called value. And all I'm doing here is I am memoizing the current value that we're on into a variable so that we can manipulate it a little easier. And then we're going to declare a very interesting variable called current sum already positive. So what this means is exactly what it sounds like. Is current sum already positive at the beginning of our for loop? Now you might be wondering, what is the purpose of this? Well, the thing is that because we are going to be manipulating current sum, right, we're going to be adding value to it or deciding maybe to replace it with something, it's very valuable to us to keep track of the sign of current sum as it is at the start of the loop. Okay, so this is where we're going to start to use it. We're going to say if bang, current sum already positive. So meaning if current sum is negative or 0, and current sum is less than value, and the current sum that we're on is less than the current value that we've iterated to, replace current sum with value. So this should make good intuitive sense, right? If we've, gotten to this position in the array, current sum is 0, the value is 3, there's no point keeping the 0. It doesn't do anything for us, so we just grab the 3. Likewise, when we get to here, right, the sum, current sum is -7, no point keeping the -7, just start over at the 5. Cool. Else, so if we decide not to replace current sum with the value, we are going to increment current sum by the value. Then we're going to check if current sum was already positive and current sum is less than 0, set current sum to 0. So this is really interesting. This is why we had to keep this. What we're saying here is if current sum was already positive before we added this value to it, and adding this value to it has turned current sum negative, then we want to ignore this current value that we're on because it's not helpful to us, and we're going to need to reset it to 0. And what that looks like is right here, right? So what happens here when we hit this -10 and we add it to the 3 is that, it was positive before. Adding the -10 now makes this -7. -7 is definitely less than 0. Let's just reset current sum to 0. And what that's going to do is that's going to hit this if condition at the next number and allow us to reset current sum. Okay, at the end of this, we say if current sum is greater than max sum, then simply set maxSum to current sum. And then finally, at the end of the loop, we will return maxSum. Okay, because this is a little complicated, let's step through this example together. So, at the beginning, maxSum and currentSum are both set to the value at the 0 index. The value at the 0 index of this array happens to be 1. maxSum is 1, currentSum is 1. Cool. And then we're going to iterate through the array. First value of the array, starting at index 1, is going to be -1. Is currentSum already positive? Is going to evaluate to true. All right. So, because this evaluates to true, and we've put a bang here, we immediately know we're not going to hit this if condition, right? CurrentSum is already positive, so bang of that is negative. Cool. So we get into here. CurrentSum plus equals value. Because value is -1, currentSum is 1, currentSum now becomes 0. Okay. If currentSum was already positive, which is true, and currentSum is less than 0, reset currentSum to 0. Well, currentSum is now 0, which is not less than 0, so we don't need to reset. And then finally, if currentSum is greater than maxSum, well, 0 is not greater than 1, so we do nothing. Great. Now, I is going to be equal to 2. And now, value is going to be equal to 3. Is currentSum already positive? 0 is not greater than 0, so this evaluates to false. Okay. If currentSum is not already positive, which in this case is true, and currentSum is less than the value, is 0 less than 3? Yes, it is. Then we're going to reset currentSum to value. Okay, so we're going to reset currentSum to 3, which remember is our current value. That skips this block. If currentSum is greater than maxSum, yes, 3 is bigger than 0, maxSum becomes currentSum. Great, maxSum is now 3. Okay, I is now equal to 3. Value is now equal to -10. And is currentSum already positive? CurrentSum is 3, so that is a true. So because this evaluates the true, we skip this block. We get into here. CurrentSum plus equals value. 3 plus -10 is -7. If currentSum was already positive and currentSum is now less than 0 after we added the value to it, reset currentSum to 0. So, was it already positive? Yes. Is -7 less than 0? Also yes. CurrentSum becomes 0. Okay, is 0 greater than 3? Nope. maxSum stays as it is. Cool. I is now equal to 4. Value is now equal to 5. Okay. Is currentSum already positive? This becomes false because 0 is not positive. So this now evaluates to true. Is currentSum, which remember is 0, is less than the value, which remember is 5, then we're going to reset currentSum to the value. So this now becomes 5. Okay, we skip this block. We hit here. Is currentSum greater than maxSum? Is 5 bigger than 3? 5 is in fact bigger than 3. maxSum becomes 5. Okay, final value. I is now equal to 5. Value is now equal to 10. Is currentSum already positive? Is 5 positive? Yes, it is. So because 5 is positive, we skip this block. We hit here. CurrentSum plus equals value. We're going to add 10 to 5. So currentSum is now 15. If currentSum is already positive and currentSum is less than 0, 15 is not less than 0, so we skip this. And now we hit this condition. Is 15 greater than 5? Absolutely. maxSum is 15. And that completes our for loop. We return the maxSum, and we get our answer, which is going to be 15. Let's get to the fun part. Let's run our algorithm. Okay, as you can see, this is a pretty performant piece of code, and we've already done some big O analysis for this. You know, this is a single for loop, this is an O of n solution, and hopefully now you have a better understanding of how to solve max